In part 1, we looked at the development of animation. We saw that we could mount a disc like this on a device called the zoopraxiscope and spin the disc while looking through the slits at a mirror. This had the visual effect of freezing the spinning wheel, showing us just one frame of the animation at a time. Let's now spin the wheel and see the animation. So this is just the disc spinning, where each frame is the previous frame, but rotated 1/13 of the way around. So after 13 steps, we're back to where we began. And you'll notice that each pair of dancers is executing the very same motion, just one step behind the others. So focus on the pair at the bottom. They actually look like they're dancing. And if we set things up so we're just looking at those, it's going to look pretty good. And that's what the slits do for us. The slits let us see the dancers only when they're in position. And then once the slit moves past our eye, we're just looking at the back of the card. But again, because of the way our brain is wired, we retain the sense of the image we just saw for a very brief moment, just long enough for the next slit to come along. So you see a picture and you hold it in your mind until the next one arrives. And then you hold that until the next one arrives. And if they come quickly enough, you won't get the sense that there's black fields in between them. You get the sense that it's a single continuous motion. Well, people tried lots of different technologies for making these kinds of things. Another very famous technology was called the zoetrope. And here we have the same idea, but we're wrapping it around a cylinder. And you can see the pictures of a little man on a horse at the bottom of the cylinder. And the vertical slits run around the outside. The cylinder sits upright like a cup, and you would face it from the side and spin the cylinder looking through the slots. If you want to do this experiment yourself, you absolutely can. Just go out and get a colander, something for, cleaning your salad or draining pasta. And often they have these vertical slits running around the outside for draining water, but they're just perfect for this use. And so in this example, you can see we have the phases of the moon taped around the inside of the bowl, and then put the colander on top of any kitchen gadget that spins. And now if you put your face on one side of this and you spin it, you get the very same sort of effect that we got from the earlier devices, where whenever you can see through the slit, you get to see the moon on the other side. And if you run this, you absolutely can do this. It's great fun. And you see the moon, the phases of the moon changing. This approach really has a lot of limitations. It's hard to get constant speed. You don't get a very long animation, and the animation has to be cyclical. Otherwise, you get an abrupt start and stop each time you complete one turn. To address these, people worked out a whole lot of technologies and eventually ended up with movie film. Here's a very simple program that I wrote to demonstrate some of these ideas. On the left, we have the movie itself, which I'm showing you as a series of columns, a series of pieces of film. But the idea is that this is one long movie, but I have to break it up into two pieces to draw it. So the left-hand column shows the first half of the movie, and then imagine that the second column on the right is just taped to the bottom of the one on the left. So reading it from the upper left, we have a very simple scene of two vertical bars with a ball in the upper left. As we read down the column, the ball moves down and to the right, and then starting again at the top of the second column, the ball finishes its path and ends up in the bottom right-hand corner. So let's see what this looks like. In order to experiment with how different frame rates, different numbers of frames per second, affect our sensation of smoothness, I've decided I'm going to always show the movie at 2 seconds long, and I will add or subtract frames. So if we show many, many more frames in that 2-second window, they come by faster. If we have fewer frames, they come by slower. So on the right-hand side, you see that big rectangle? That's where the movie is going to show up. And when I start the movie, we'll have 3 balls. They count down 3, 2, 1, so we know when the movie begins, and then we watch it. So let's watch this movie. Right now, I have 30 frames. Each one of these vertical columns holds 15 images. So this is a 30-frame movie, which is going to play over 2 seconds. So this is 15 frames per second. Now, depending on how large this is on your computer and any compression information that might have gotten lost along the way when this video got compressed, and the particular graphics card inside your machine, your computer may or may not have the ability to keep up with every single little bit of the information that I'm putting into the video. But to me, when I watch this movie, it looks a little bit jerky. It doesn't look completely smooth. I'll run through it again. You can also, in addition to watching the movie on the right, you can watch on the left. I draw a red box around each frame as it gets played. So you can keep an eye on that as well. So let's run the movie again. So that's 15 frames per second. And it's looking a little bit herky-jerky to me. To explore this a little bit better, I'll tell you what, I can control how many frames we draw. So I'm going to back this way off, and I'm going to say, in fact, I'm going to say we have a movie of just 2 frames. That's about as minimal as it can be. So let's run it. 2 frames over the course of 2 seconds. That's obviously 1 second per frame. Frame 1, frame 2. And there's no sense of motion. All right, let's add 1 more frame. So now we have 3 frames. So now each frame only lasts 2/3 of a second. Well, it doesn't look anything like smooth, but it looks a little bit more like maybe there's an animation happening. So let's get one of these columns. So here's 15 frames over 2 seconds. Now, to me, I definitely got the impression of motion. It didn't look smooth, but it did look like it was moving. So here's 30 frames. This is back where we began. 15 frames per second. Well, it doesn't look great. So tell you what, let's add another 15 frames into our column. So now we have a movie that's 45 frames long. And I'm going to show all 45 frames in 2 seconds. Well, that's starting to look pretty smooth to me. So let's go up and add a 4th vertical column of frames. So now I have 60 frames. 60 frames in 2 seconds is 30 frames per second. Let's see how that looks. Well, to my eye, that's looking pretty good. That's looking pretty smooth. Let's try it again. And again, remember we're showing 30 frames every second. So at 30 frames per second, it looks nice and smooth to me. And if I take it way down, let's say 5 frames per second, just as an extreme. So here's 5 frames in 2 seconds. Not smooth at all. So let's go back up, add all 60 frames back in. Let's see how that looks. Processing's default frame rate is 60 frames per second, twice as fast as what you've just seen here. Processing gives us a way to really easily control what we draw on every frame. And it all hinges around the idea of a variable that processing maintains for us called frame count. Frame count is the key to creating animation. And in fact, this little demonstration video is using frame count to create the little movies when I run them for you. There's a video on frame count that discusses how to use that variable to create animation in processing.